Welcome to Converting Between Grams and Moles. Now that we know how to calculate the mass of 1 mole of a substance, we want to be able to calculate the mass of any number of moles of that substance. This is essentially a unit conversion problem where we are converting from moles to grams. So, this brings us to the grams prompt. A prompt is a word or phrase that tells us what to do next. In chemistry, certain words, phrases, or conditions can prompt us to write relationships that can help us in problem solving. So, memorize the grams prompt. In your wanted or data section, if you see grams or prefix grams of a substance with a known formula, so prefix grams there means milligrams or kilograms, something like that, then calculate the molar mass of that formula. Write that molar mass as an equality in your data section. So, 1 mole of that compound equals whatever the molar mass is of that compound. If you see grams of a formula in a calculation problem, you will almost always need the molar mass to solve the problem. So, use the molar mass as a conversion factor. For example, to find the mass in grams of 0.25 moles of oxygen, first we want to write the wanted unit and the substance. So we want the number of grams of oxygen, of O2, and then we'll put our equal sign. Next we want to write our data, including the molar mass of the known formula. So in the data, we have 0.25 moles of O2. That's our given, so that's going to be boxed. And then we have a formula, O2. So we need to write 1 mole of O2 equals 32.0 grams of O2. And next, we can use our conversion factor to solve. So we have our wanted, our data, and now in our solve section, we have, again, our wanted portion. We write that down there. And now we write in our given 0.25 moles of O2. Now we use our equality here to give us a conversion factor. We have moles of O2, so we want moles of O2 on the bottom. And we want grams of O2 on the top, and then we write in 32 grams of O2 per 1 mole of O2. And now our moles of O2 cancel, and we have 0.25 times 32.0 grams divided by 1 mole, and we get 8.0 grams of O2. So then you need to check to make sure the resulting unit is in fact the wanted unit. It's also good practice to check your calculation and to answer against an estimate of the answer. So 0.25 moles of O2 is 1/4 of a mole, so the mass should be 1/4 of the molar mass. 1/4 of 32 is 8, so 8 grams of O2 is in fact a reasonable answer. By writing the molar mass equality, then you ensure that you have all the information you need to solve the problem in the data section. When you don't know how to solve a problem, begin by writing the wanted and the data sections. Writing any relevant conversion factors in the data section will often help show you what you need to do next. So please take the time to do that. This strategy will cost you some time up front, but likely it will save you plenty of time by preventing you from spinning your wheels and getting frustrated because you don't know what to do next. So invest a little bit of time now. When you start every problem, when you get in the habit of it, then you'll be much faster at actually solving problems. So, just as we can convert from moles to grams, we can also convert from grams to moles. For example, how many moles are in 4.00 grams of O2? Well, let's write the wanted and data sections, including the molar mass equality for O2. So, we want number of moles of O2. In the data section, we have a given of 4.00 grams of O2. And now we have our equality, 1 mole of O2 equals 32.0 grams of O2. And now we can solve it. So we write our given, 4.00 grams of O2. Now we have our conversion factor. We know that 32.0 grams of O2 gives 1 mole of O2. And we have grams here, so we need grams in the denominator, in the bottom there. And now our grams of O2 will cancel, and we will be left with moles of O2. And then we have 4.0 times 1 divided by 32.0, and that gives us 0.125 moles of O2. And now let's check to see if our answer is reasonable. 4 grams is 1/8 of 32 grams, so our answer should be 1/8 of a mole. 1/8 is in fact 0.125, so our answer is reasonable. That was converting between grams and mole.